So hello everybody, and given the hour also, good morning. So my name is Ferdinando Papale, and I am a mostly .NET developer at MongoDB in Copenhagen. And the reason why I'm here is that I would like to tell you a little bit about why we decided to move away from IL weaving, and we started using source generators in the .NET SDK of Realm. So who has heard about Realm before? One person, amazing. So I will tell you more about it later, but Realm is an object-oriented database that is mostly targeting mobile. So just to set up the context, we are going to talk about code generation in .NET. This is because both IL weaving and source generators are two different techniques that can be used to generate code in .NET. And we are talking about the stupid type of code generation, not AI code generation or something like that. So just normal code generation, let's say. So in particular, we're going to see how these were used in the Realm SDK, and how and why we decided to move from one approach from the other, and what we got from it. So before going into this part, though, you have to get an introduction about what is IL weaving and what are source generators. Okay, first of all, so what is IL weaving? So when you compile C# code, it gets compiled first to something called IL, that stands for Intermediate Language. That is a sort of high-level assembly. Then, depending on your configuration, it either gets compiled to machine code at runtime, if you're using JIT, or ahead of time if you're using AOT. But there is always this intermediate step with the IL. And if you ever work with Java, this is a very similar idea to bytecode. So this is a platform-independent code that then gets converted to machine code when it's necessary. So IL weaving essentially is the process of modifying the IL code in some way to do something. It almost feels like magic because you can modify everything with IL weaving. You can add classes, change the behavior methods, change attributes, and so on. One important thing to remember is that IL weaving happens after compilation. So the code already needs to be in a compilable state before the IL weaving is doing anything. And another thing to remember is that this is not visible to the user. This is happening after the code is compiled, so the user doesn't know that anything has happened. So why is this useful? Well, it's useful to generate repetitive or optimized code. Just to give you an example about how IL code looks like. So if you have a property, like the one you see on the left, with the string name property, what you have on the right is the getter and setter in IL. It's not important that you understand what is happening here, but it's just to give you an idea about how IL code looks like. And as you can see, it's not really easy to understand what is happening if you don't have experience with it. Okay. Now, to give you an idea about a library that is using IL weaving, and maybe you have used or that could be interesting, there is Propertychanged.fody. So if you ever worked with any MVVM framework like Maui, Xamarin, Avalonia, Uno, and so on, then you know that if you want to bind something to the UI, you need to implement iNotify property change. The only thing that is on this property is this event called, on this interface is this property change event. And the contract here is that if you're implementing this interface, then every time one of the properties that are in the object are changing, you should raise this event with the name of the property that is changed. So this is used by this framework so that they get these notifications and the UI gets updated. Now, if you have to do this yourself, then from a class like what you see here on the left, you have to do what you see here on the right. So essentially, what is happening is that you need to have a begging field for all the properties, and then every time a property changes, you need to check if the new value is equal to the previous one. Then you need to set the begging field, and then you need to invoke this event that in this case is inside this onPropertyChange method that you see on the bottom. As you can imagine, this is a lot of code for doing not much. And it's repetitive, and it's also error prone. For example, if you have dependent properties. For example, if you have a full name that is dependent on the first name and the surname. So in this case, you need to take care of these two. So what Propertychanged.fody is doing essentially is going into your DLL after it has been compiled, finding classes that are declared implementing this iNotify property change interface, and change the IL so that the notifications are raised correctly when the properties are changed. One important thing to know is that all of this is invisible to the user. So if you have this library in your code, you will still be able to see what you have here on the left. What you have here on the right, it's not visible, at least in the IDE. But we'll see in a second how you can see it. So now, okay, how do you see IL code? How do you see Swift code? This depends. What do you want to do? If, for example, you're just curious about how IL code looks like for something simple, for something that you can just copy-paste and so on, then you can use something like SharpLab. That is an online .NET playground, and that is useful for various different reasons. But you can go here, and you can write something. Like this. I could have written before, but okay. So, and then here on the right, you can see the corresponding IL code. For example, here you see the getter for the name property. And if you select the body, you also have this, this gray background. And on the left, it shows to which part of the code it corresponds. And actually, if you go over, it will also tell you what are these instructions doing, if you're interested in that. OK, so this is one possibility that you can use. If you're interested in how the IL code looks like for your code, for your project, or you want to see what is the effect of IL weaving, then you need to use something like ILSpy or any other decompiler. So, and I have a small example about it here. So here I have this person property change class that is declared is implementing this iNotify property change. And in this project, I've already added Propertychanged.fody that I've talked about a second ago. So as you can see, this is the definition of the class. I didn't do anything here. Now, if you get ILSpy, and then you open the DLL after compilation, then you can navigate to your class. So you need to find first the namespace and then the class. OK, you can go here and select IL, and you will be able to see all of this. That is extremely unfriendly. So if you want to understand what is happening, you can select the C# here, and you can see actually the compiled code, so the way that it works. So, for example, if we take here the name property, as you can see, both the setters and getters have been changed to do what I've said before. So in this case, the setter is checking if the new name property is the same as before. If it's not, then we set the breaking field, and then it calls this onPropertyChange method. That is also something that has been created by the weaving. And all of this is completely invisible to the IDE. So if you don't know what if you have a library that's using IL weaving, the only way to really know what is happening is to use a decompiler, because otherwise this is invisible to you. But anyway, regarding this library, you can imagine that this is particularly useful if you are working in this kind of MVVM framework, even though nowadays there are also alternatives to this that are using also sort generators. OK, so this was just to give you an idea about how to look at IL code. OK, so now you know what is IL weaving. At least you should have like a general idea. Now we need to look at sort generators. So sort generators were a compiler feature that was added in .NET 5 and are part of the compilation pipeline. Essentially, when there are sort generators in your project, the compilation happens like you see in this screenshot that I've taken from the documentation. So there is a first step of the compilation Then there is the source generator part of the compilation, in which the compiler creates something that is called the compilation object that is passed to the source generator. With this compilation object, the source generator can look into the project code, both from a syntactic and a semantic level, and then the source generator can eventually generate new source code. It doesn't need to, but it can. Then these new files are added to the compilation, and the compilation continues. So source generators are only useful to generate new code. You cannot modify existing code, and this is one of the biggest differences with aisle weaving. With weaving, you can modify what's already there, and you can add new things. With source generators, you can only add things. They are only additive. And another big difference is that source generators are the source generation is happening during the compilation. It's not something that is happening afterwards. So why are they useful? Well, their camp of applicability, let's say, it's very similar to the one of aisle weaving, even though they have some differences. So they're very useful to generate repetitive or optimized code. For example, if you have ever used system.text.json, then this is using a source generator, at least since .NET 6, if I remember correctly. So system.text.json is a library that you can use to serialize and deserialize JSON object. And the way that it works is that you define your class somewhere in your code. Then then somewhere else you have this class that is deriving from JSON serializer context, and that is decorated with this attribute that has the type of the object that this context should be responsible for. This class needs to be partial because source generators are additive, so the source generator then is going into your code that's generating a lot of other things. And then when you need to serialize something, you need to pass not only the object, but also this context. Okay. But this library has existed much earlier than source generators. So the reason why they decided to use source generators now is that traditionally, this library was using reflection. So there are some issues with reflection. First of all, nowadays it's also getting a little bit of pushback because there is a lot of push for AOT. So this could be problematic in AOT environment. And also it's not very performant because all of this is happening at runtime. So what the source generator is doing essentially is analyzing your code, looking at the properties, looking at the type, and then generating the serialization already at compile time. So this is much more efficient. And according to the benchmark, this is at least twice as fast as the runtime reflection approach. Okay. So this was just to give you an idea about another source generator. Okay. So how do you see source-generated code? Well, this really depends on your IDE. If you're like me and you are using Visual Studio for Mac, then you're out of luck because you cannot see them. If you're using Visual Studio for Windows, the traditional one, then you need to go inside your dependencies under the analyzers. Maybe it's a little bit confusing. And then you can find the libraries that have either an analyzer and the source generator. And then if you expand them, you're able to see the generated files. And they have this beautiful yellow banner that tells you that it's generated, so you cannot actually change it. Actually, if you want, one important thing also is that these files are visible from your IDE, but are not visible on your file system. If you want, you can change something in the project file to make them, to have them emitted on your file system, but it's not something that is set on by default. And also, if you do it, you need also to remove them from the compilation. Otherwise, you will get errors, just as a note. Okay. So now you have an idea about what is weaving. You have an idea about what are source generator. Now we need to take a look a little bit at Realm. So Realm is a reactive, object-oriented, cross-platform database that has been created mostly with mobile in mind, so with devices with lower capabilities, let's say. And it's available for a lot of programming languages like C#, of course, Swift, Kotlin, TypeScript, and so on. And it has a lot of nice features, among which device sync that allows to synchronize automatically objects between multiple devices, and with Atlas, so MongoDB on the cloud. Those are not the important features. There are two important things that are necessary for the rest of this talk. So first of all, Realm is object-oriented, and this means that when you work with Realm, there is no translation layer, there is no mapping done, there is no ORM. Everything works with objects natively. So if you're using a library that is wrapping a SQL database, then you have a translation layer that is converting what you get from SQL to your objects. This is not happening with Realm because everything is already an object. And another important thing is that Realm objects are live. So this means that when you get the value of the property of a Realm object, this value is coming directly from the database. If you're setting the value of a property, you're setting it into the database. So this means that the objects that you get from Realm, the objects, the collections, and so on, always reflect the latest data that is stored in Realm. This is very different to a database that is using, for example, SQL, because in that case, when you do a query, you are getting some data in your objects, and then this data is static. If you change something in your data, then it's not reflected in the database. And the data that you have there reflect the state of the object at the time that you did the query. Instead, with Realm, you always get the latest data. And you can also do it, you can also freeze, let's say, the objects so they keep the same data, but that's another thing. And I have a small example actually to show you how does this look in a project. Okay, so maybe going a little bit line by line. So on the top, I'm getting an instance of a Realm, so an instance of my database. Then I'm creating a GUID just that I'm using as a primary key, so that I can retrieve the object later. Then I have this realm.write. In this case, write is the equivalent of a write transaction in an SQL database. Then I'm calling add to add an object. And I'm adding this person where the ID is the GUID that I just created, the name is Mario, and the age is 22. Then what I'm doing here is that I am calling realm.find to find this object in the database, and I'm passing the primary key. And I'm assigning it to this person1 variable, and I'm doing this a second time to assign it to another variable. This is just to have two different objects that are two different objects in memory that are pointing to the same objects in database. Believe me when I tell you that find is not using any kind of caching, so these are two different C# objects. Okay. So what I'm doing now is that I have a new write transaction and I'm changing the value of the age of person1 to 40. And then later I'm just printing the age of person1 and the age of person2. So if you run this, let me put it on the side and maybe make it a little bit bigger. Okay. So, I mean, not surprisingly, the age of person1 has become 40. That's not very surprising. Maybe the surprising thing is that also person2.age has become 40. And why this is happening? This is happening because even though person1 and person2 are two different objects, they're actually pointing to the same object in the database. So when you get the value, you are getting it directly from the database. That's why, and that's why Realm objects are live. This was just to give you an idea about how it looks like. Okay. So now you have an idea about what is isle weaving, you have an idea about what are search generator and how Realm, what is Realm. Now we need to take a look at why we decided to use these code generation techniques in the first place and why we decided to move from using one approach to the other. So when the library was created, that was before my time, they decided to use isle weaving. And they decided to use isle weaving behind the model definition. So what you have here on the left is how developers could write a model for a Realm object. And I was discussing about this yesterday with someone. In Realm, your your objects are your schema. There is no other schema defined anywhere else. So the way that you define your objects is your schema. Okay. So as you can see, in order to define the realm object, you just define a class that is deriving from this realm object. Then you define the properties like you will do normally with the setters and getters. There are also some attributes like primary key, because this is a database, and that's it. It looks almost like a plain old C# object, apart from deriving from this realm object class. Okay. Now, as I said before, realm objects are live, so what we were doing with weaving is what you see here on the right. Essentially, we were going into the user code after the compilation, and we're modifying the setters and getters of the properties to call getValue and setValue. Without going too much into details, setValue and getValue are methods that are getting the value from the database or setting the value in the database. One important thing here is that what you see here on the right, it's an extremely simplified version of what is the weaver doing. This is because the way that the setters and getters need to be modified depends on the type of the property. It depends also on the state of the object. So if the object has been already added to the database or not. Because if the object has not been added to the database, then it works like a normal C# object. There is nothing else happening. So what you see here, it's a very simplified version. This also gets much more complicated for collections and so on. So this was just to give you an idea. So now the question is, so why did we decide to do this? Well, we decided to do this because we want to give developer the best experience. So the idea here is that developers, when they're working with the Realm, they're working with something that looks like at least a native C# object. When you're working Realm, you don't need to worry about calling getValue, setValue, or anything else. You just use the object like you will use another C# object, and then we, behind the scenes, take care of changing the setters and getters so that they go directly into the database. So, and as I said before, this is something that is actually hidden from developers. You could have looked at it if you were using a decompiler, of course. And just to give you an idea, so what you see here on the left is the way that a getter looks like before weaving, and on the right you have the getter after weaving. And this is only for a string property, so it gets much more complicated for other kind of properties. So this is just to give you an idea about how it looks like. It doesn't really matter to understand everything. Okay, so as I said before, isle weaving is an extremely powerful technique because it allowed us to hide a lot of complexity behind the model definition, so that users don't need to worry about how Realm works internally. But it also has some major drawbacks. So first of all, it's not really the code that you produce with isle weaving is not really readable. IL code is made by a series of instructions that looks almost like assembly, so it's difficult to work with it. And this also means that it's very difficult to extend this part of our code. And this is obviously part of our code, but this is something that is very limited in scope because this is only about the model definition. So when we had to work with it, you need to work on something that is completely different from the rest of your code. And just to give you an idea about how the code that was doing the weaving looks like, you have it here on the left. So as you can see, it's a series of insert, insert, insert. Then you're creating these instructions and so on. And this is only for a very simple property. So this gets much more complicated because we were also using weaving for some other things. Okay. Another problem with weaving is that the changes are not visible for the final user. So this almost feels like magic. Developers don't know exactly what has happened to their code, but it works in a certain way. There is another problem, is that weavers can interfere with each other. Because they can modify everything, when you have multiple weavers in your code, then you need to consider the fact that there could be another weaver that could be working on the same code. So you could have some unpredictable effects. And that depends essentially on the order of weaving. Even in our case, for example, this Propertychanged.fody library that I've shown you before, this is a library that is implementing iNotify property change. But this is also something that we are doing because we have internal notifications. So we had to take care of this, essentially, so that we don't do the same thing together. And another problem is that the code is not debuggable. It's not debuggable because your debugger has no code to jump to. So if, in this case, it's only setters and getters, so maybe you don't expect to be able to step into setters and getters. But still, even if it was for methods, you will not be able to debug it. OK. And there is another big problem with weaving, and that weaving is not part of the compilation. So when you're working weaving, as I said before, you are working with something that happens after the compilation has been done. So this means that the code already should be in a compilable state. You cannot have error in your code and then wait for the weaver to come and fix something for you. So what is the problem? Well, a lot of developers asked us, why if I want to declare a realm object, this needs to derive from the realm object class, right? Why do I need to have a base class? Why can't I simply have an interface? Well, essentially, this was the reason. It's because if we had the classes declared as implementing this iRealm object interface, like you have here, then this code needs to be compiled somehow. So the developers will need to go and then auto-implement this interface, maybe with this not implement exception for the properties and the methods. And this looks extremely ugly. So then what we will do is that we will go into the code and then change the essentially change the way that all these properties and these methods are working. So we decided not to do this for a couple of reasons. First of all, this is extremely ugly. Can you imagine doing this for all your objects from your database? It looks really bad. And also, this is really this gives a really bad experience because you have all these methods that seemingly are just throwing exception all the way, then you run the code and your code is working as normally. So it feels very strange. Another problem with this is that if we had to do this, this means that all these properties, all these methods, we will need to weave them. We'll need to do them in the weaver. And as I said before, working with the weaver is extremely annoying. So instead, with the approach that we had, with having a base class, all these methods, or at least the majority of them, were implementing in the base class that was in our project. So it was much easier to manage. But this is, in the end, it's a matter of developer experience. We decided to not go this way because it looks extremely bad and it gives overall a bad feeling about working with the library. Okay. Then at some point, with .NET 5, source generators came along, and after, I think after 1 year and something, we decided to give it a go because they were giving more and more tractions. And we decided to move our approach from using isle weaving to use source generators. And in this time, we also had the possibility of doing some changes related to how Realm works internally. So we also had to change the way that the model definition was, how the model could be defined. So what you have here on the left in this classic model, this is the way that developers could define their classes before with weaving. So you have your class, you have your properties, and then you have your class deriving from Realm object. What you have here on the right is the new model definition, so the one with the source generator approach. The properties look the same, the attributes look the same. The two major differences are that the class is partial, and that instead of having a base class, now we can finally have this interface. Why does it need to be partial? Because what is happening with the source generator is that we are looking at your code during compilation, and then we are we have another file with the rest of the definition of this class that is essentially implementing this NET object interface. So we are doing all the things that, we are doing all the implementation for you. So all the things that before were in this Realm object class now are in your code base and are implementing by this Realm object interface. And as you can see, essentially the moving from the previous approach to the new approach doesn't require too much time. You just need to really change 2 words in your models. And then this is essentially works in the same way for developers. There is no other difference in the behavior. So it's just a matter of convenience, let's say. Okay. So just to give you an idea, this is part of the code that gets generated for a class, for a person class with 1 string property. And there is actually much more happening underneath. And so this was just to give you an idea. Maybe something that I forgot to mention before is that if you want to take a look at any of this Realm is open source and is free to use, at least for the local version. So you can go and take a look if you're curious about how all of this is implemented. Okay. So as I said, third generation for us has a lot of advantages over aisle weaving. First of all, the code that we are generating is essentially readable and debuggable. You can even developers can go and take a look at what kind of code we are generating. Also, it's debuggable because essentially now there is code that the debugger can jump to. And because you are working with C# code that you already should know how it looks like, then it's much easier to understand what is happening and it's much easier to generate this code. This meant also that we had the possibility of working in a much easier way on some new features that were regarding the model definition. And that was something that was very difficult to do before. Because imagine that you have to add a new type to your database. Then if you have to do it with weaving, it's really a pain. With third generators, it's still a little pain, but it's much better. And another important thing is that this is part of the compilation pipeline. You don't have problem with interference between third generators, and this is something that the ecosystem is pushing to. So this is something that will already has a lot of attention, but will get more and more attention. There are also some problems with third generators. One smaller thing maybe is the fact is that you're generating text, and in the end, it doesn't really matter how your code looks like as long as it compiles. But if you want to be nice and you want your code to be readable by developers, then you need to take care of it. Because there are no internal features that allow you, for example, to fix the formatting. So you need to do it yourself. I admit this is a smaller problem. Then performance. So with weaving, the modifications are happening after compilation. So once you compile, this is done once. With third generators, this is something that is happening while you're typing your code. And as a developer of a third generator, you have no control over when this happens. This needs to be like this because, for example, third generators can implement interface. So if the third generator does run, you don't have the implementation of the interface and you will have an error. So it makes sense. But you need to take care that your third generator is not doing unnecessary work. There are also approaches that allows you to, like incremental generator, that allows you to improve on this. But this is something that, for example, is only available from .NET 6 onwards. And there is also another problem. The biggest problem for us about third generators is that they're only additive. They can only add new things. They cannot modify what is already there. And this means that I kind of lied to you because we didn't completely remove IL weaving. We only reduced it. So, and why is that? Well, what you have here on the left, this is the model definition with weaving. You have your class deriving from Realm object. You have your properties with setters and getters. Now, if we had to go to a 100% source-generated approach, then it will need to look like what you have here in the middle. And why is that? Well, if you have your properties already defined, then we cannot go into your code and define properties with the same name. That you cannot do. So we will need to use a different approach. So, for example, you will need to declare your properties as fields, and then we will go into your code, look these fields, and then generate properties with the same name. This is something that is used, for example, by, if you're working with MAUI, Xamarin, and so on, by MVVM toolkit, that inside also has has some features to allow you to implement automatically iNotify property change. So what they do is that they look at these private fields, and then they implement the properties that are using these baking fields for to implement iNotify property change. Okay, so why we decided to go against this? Well, one reason is that moving from the previous approach to this approach will require more work, because now all the properties need to be fields. So you will need to change something in your code, first of all. Second of all, this feels kind of wrong, because at least with MVVM toolkit, these fields are used by the code that is being generated, because these are the baking fields of your properties. With Realm, these fields are only a blueprint and have no use, at least, for example, when the object is coming from the database, because we don't really use the baking fields of properties. So these will just be there and will have no use. And it looks confusing. So overall, in order to keep the developer experience the same, we decided not to go for a 100% source-generated approach. And we decided to go for the approach that I've shown you before. So this one that I have here on the right. So essentially, the property definition is the same. So you don't need to worry about fields. And then the difference is that you have a partial class, and then you have a property. And another problem, now that I remember, another problem with the approach here in the middle is that with what we allow is that your properties can be of any accessibility. So your properties can be public, private, protected. They are still managed by the database, let's say. If we had to do something like this, then we will need to maybe add other attributes so that you can specify how you want your properties to be generated, and it looks even worse. So this is just to give you an idea. Okay, but in the end, we decided for this mixed approach in which we greatly reduce the amount of source generation that we are doing. Okay, now, what exactly are we doing with source generators now? So we are doing what you see here on the right. We are still modifying the setters and getters, but now instead of calling a method, we are essentially getting and setting the value on a property with the same name on something called the accessor. And I'm not going to go too much into details, but the accessor is something that we are also generating. So I know that this one on the right, I think it looks very similar to this one that I've shown in the beginning that was being done by weaving. But this is an extremely simplified version of what is happening. This is just from a very high level. Instead, what we have now with the weaving, this is 100% what the weaving is doing. So this is the same for all properties. This is the same independently from the object state. This is the same in any case. So this is very few lines to do in IL weaving. So what did we do instead? So all the complexity that before we had in the weaver, now it's in the accessor. But this is much better for us because the accessor is something that we are source generating. So instead of needing to write IL code to do all these checks, all this for the property types and so on, then all these checks are done inside the accessor. So it's much easier for us to modify the way that the setters and getters work. So we still have weaving, but it's very limited compared to what we had before. So we worked on this. We started working on this about maybe 2 years ago, and now I'm really bad with dates. And we worked on this for about 6 months. 6 months was not. I mean, this time it's from the beginning till the end, and so it also regards other kind of work, and it also includes the fact that we had to modify a lot of things that were happening inside the internals of Realm, because, for example, we moved from a base class to an interface. And we published the first version of the Realm source generator in November 2022, so 1 year and something ago. And by the way, in the beginning, the Realm.source generator was a separate package that was getting picked up when you were getting Realm. Now instead, it's inside Realm. And so the classic model definition, so the one with weaving with the base class, it's still supported if you want to use it. But we are really pushing developers for adopting the new source generated classes. And so the fact that we moved to source generators also allowed us to add some features that we wanted to implement for some time, but it would have been a pain to do with weaving. For example, the support for nullability in the model definition. That was something that was requested by us. We're also planning to add incremental generator that is a source generator that is caching some parts, so it's not so performance hungry as a normal source generator. But we still didn't start with this. Also because generally Realm is something that is used in mobile applications, and normally you don't have the projects are not huge, and you don't have like a huge amount of models. So far we didn't have any complaints regarding performance of the source generator that we have. Yes, and going forward anyway, we would like to move completely to the developers anyway to this source generator approach. And our idea is to try to add as little as possible to the weaved classes. Okay, so this is our dream, completely remove IL weaving. But this is not something that we can do in an easy way if we want to keep the developer experience the same and if we want to keep the model definition the same. The way that we could do it is that if the language would allow partial properties. As you can see from this issue on GitHub, there is a lot of requests for this. And actually, this screenshot is coming from, I think, 3-4 months ago. I checked yesterday, the numbers are higher. So if we had partial properties, then we wouldn't need to have the weaving, because then we can go and generate the implementation of the setters and the getters for you. So this is not something that we have control on, but if you want it, just go and vote it. And this is something that is getting more and more attention also because source generators are getting more and more attention, especially now that native AOT is getting also tractions, and developers are trying to go away from using reflection. Source generation doesn't do the same thing that reflection can do, but it can offer an help in that direction. And recently, this is a slide that I actually just added, there's also been a talk about interceptors. So interceptors have been added in .NET 6 as an experimental feature. The idea with interceptors is that in somewhere in your code, you have an interceptor method that is intercepting another method that is as this path at this row, this line, and at this column. And the idea that when that method is called, instead of that method being called, you have this method. So essentially, you're doing code substitution. The thing here is that this allows source generators to be, they're still only additive, but this allows source generator to modify code that already exists. So unfortunately, first of all, this is still an experimental feature, so we don't know if it will change, if it will go away. Probably not, because it's already used by EF, by Entity Framework, so I really doubt that they will remove it. The biggest problem is that there is no property support. So for now, this works only with methods. So it doesn't work with properties. Another problem is that, but I would say it's a different level of problem, is that our source generator will do much more work. Because now our source generator is only looking for the model classes and generating something. If this was working with properties, then we'll need to look at all your code and find all the places that you're using the properties, and then probably have 200 lines of intercept location to change the setters and getters. This is obviously if the interceptor will work in the same way for properties. That obviously I don't know. And another problem is that so our SDK is a library that is used by different developers. So we need to support multiple SDK and C# versions. So if this is something available for the latest .NET version, then maybe we could make this available, but then we'll need to find something to support also developers that cannot use interceptors. So I know that there was a lot of negativity, but it's a possibility. For now, it's just a possibility. So I don't think we're going to go this way for some time because of all these problems, but it looks promising. Because anyway, as I said, there is a lot of push for source generators to be much more than only additive. So to wrap up, so code generation has been an extremely useful technique for us because it allowed to hide the complexity of the Realm SDK essentially behind the model definition. Developers can use Realm objects as they would use C# object without needing to worry about set value, get value, type of the property, and any other things. In the beginning, we were using IL weaving that is extremely powerful because it allows to modify the code in any way, but it's also very difficult to use and gives I would say, a bad experience both to us and the developers, but I would say mostly for us that had to write the weaving. This is the reason why we decided to move to source generator that are a more modern alternative and that are also what the whole ecosystem is pushing forward. So both of these approaches have their own pros and cons, their own quirks and limitations, but overall we think that the switch was worth it. And already with the move to source generators, we were able to add for example, support for nullability, and also now we're adding another feature to help with the serialization and deserialization of objects if, for example, you are working also with MongoDB Atlas directly instead of through Realm. So it's another thing. So we think that this was overall the switch was worth it, and so far we didn't get many complaints. We didn't get any complaints actually regarding this. So we think that it was a good idea because in the end it mostly simplified our life when we have to work with this. So we think that it was definitely worth it. So this was what I had to say. If you're curious about Realm, about source generators, weaving, and some other things that I've talked about, there are some links here. And another thing that I have to say is that, so I've used the name Realm all the time, but now there is a sort of rebranding happening. So maybe if you go on the documentation, you will see that in some parts it says Atlas Device Sync SDK. So don't worry about it, but we're still talking about the same thing. I decided to use this name because this has been the name so far, so I think it's still there. And also, if you have questions, feel free to stop me somewhere. And yes, that's it. Thank you very much.